Good morning. Today we're going to work on inverses of a function again. This is part 2. It's not going to have as much explanation as part 1, so we're going to review and practice. And we're going to discuss the graphs of them and the relationship of the function and its inverse. And we're really going to focus on domain restrictions since that is where we didn't really talk enough about it in part 1. We're going to start with finding the inverse of a linear function. Okay, so first we're going to start with rewriting it, and in place of f of x, we're going to write a y. That's step 1. And if there's already a y there, then you go to step 2. Now, the purpose of an inverse is that it's a reflection over the line y equals x. The reason why that's important is because when you're reflecting over the line y equals x, your x and y switch places. So all that's going to happen on the next step is you're going to write x equals 3y plus 2. So first step was rewrite it. There is step 1. Step 2 was switch the x and y. Step 3 is solve, and it's whatever steps you need. In this case, how do we get the y by itself? Well, first we subtract 2. And the next step is to divide by 3. So x minus 2 over 3 equals y. And yes, there is more than one way to write that, but that tends to be the easiest. And step 4 is we should rewrite it in function notation. Function notation means go back to the f of x, but this is inverse, so it's a -1. And it's x minus 2 over 3. Now, I'm sorry that I ran out of room. Now, that domain and range. All linear functions and their inverses. My domain is -infinity to infinity. My range is -infinity to infinity. That is never going to change for a linear function. How do we know it's a linear function? Well, it's an x by itself. There's no square, there's no cube, an x by itself. So it's -infinity to infinity for domain and range of the function and of its inverse. So we're doing a linear again. So my domain, it needs to be the same thing. And remember, lowest point first. So -infinity to +infinity. And we use parentheses because it's an open interval. We're never going to get to infinity. We're going to try to get close to it, but we'll never actually touch it. Now, so let's go ahead and find this inverse. So step 1 was to rewrite it. Y equals 1/2 x minus 3. That's step 1. Step 2 was to switch the x and y. We switched the x and y because it's a reflection over the line y equals x. Remember when you have this graph? Y equals x is a straight line. The y-intercept is 0, up 1 over 1, up 1 over 1. So it's going to be a mirror image over that line. Okay? The next step is to solve, and we solve with as many steps as we need. In this case, my first step is going to be to add 3. So x plus 3 equals 1/2 y. How do I move that 1/2 over? I multiply both sides by 2. So when I multiply both sides by 2, I get 2x plus 6 equals y. That's my answer. Now I'm going to rewrite it in function notation. So step 4 was function notation. Step 4, so f, the inverse function, equals 2x plus 6. Okay, so that's linear. I have 2 more linear here. I want you to go ahead and try number 3 on your own. Freeze this video. When you come back, your answer will be there. Okay, let's see what we did here for number 3. We rewrote it with the y in place of f of x. Next, we switched the x and y. Okay, so we leave this one alone. First, we have to move over the 4 by doing the inverse operation, so we subtracted 4. And I actually showed my step here. I didn't show it on the last problem, but how do I get rid of a 1/3? Well, I multiply it by 3. And if I multiply it by 3 on one side, I multiply it by 3 on the other. Then I distribute into the parentheses. I get 3x minus 12. And these right here multiplied to 1, so there's an imaginary 1 there. So that is my final answer, but we rewrote it in function notation. So go ahead now, pause the video again, and I want you to give number 4 a try. Let's see how y'all did, okay? So that's my final answer. How did I get there? Well, first I rewrote it with the y in place of f of x. Then I switched the x and y like I did here. Now the next step is, how do I get y by itself? First, you have to add 7, then divide by 4. And that's your final answer. Remember that for linear, your domain is always negative infinity to infinity for domain and range, and that's for the function and the inverse. Okay, so that's all for linear for today. I'm going to jump to cubic. Well, why did I leave out quadratic? Because that's where in video 1 I saw the most struggles and the most questions and problems with quadratic. So I'm going to focus more on that today. So cubic you guys did pretty good on. The other good thing about cubics is that my domain and range again is negative infinity to infinity. And that's for domain and range. And that's for the inverse domain and range. Okay. So if you see a linear or a cubic, domain and range is negative infinity to infinity. Okay. So we're going to work these the same way we worked the linear to start with. Step 1 was we rewrite it with the y in place of f of x. Step 2 is we're going to switch the x and y. Okay, now mathematical properties, we need to get this y by itself. Now, I can't get this y by itself till everything is moved over to the other side. So my first step is to subtract 4 from both sides. Now, I can't take this cube root yet because of that 2 in front of it. How can I move that 2 to the other side? I divide by 2. Okay, now how do I get rid of a cube? How do I get rid of something being cubed? Listen carefully. I get rid of a cube by taking the cubed root of both sides. So the cubed root of x minus 4 over 2. Now, I would love us to get rid of the 2 in the fraction, but I'm going to tell you a couple things here. 1, the calculator doesn't make you get rid of the 2. 2, AP tests do not make you get rid of the fraction under there. So mathematically, we should get rid of the 2 under there, but I don't want that to overshadow this lesson. So I am going to go ahead today, and today only, let us leave the fraction underneath the radical. But I do know that a couple of you guys really want me to finish this, so I'm going to go ahead and just finish it. I'm not going to do much with it, but for those of you guys that do want to make sure that you finish solving it, I'm going to go ahead and pause the video, work it out, and you guys will have the answer there just in case. So if you were to graph this one or graph this one, guys, these are going to be the exact same graph, okay? One thing I did forget to do is to come back and write it in function notation. Make sure you have a 3 for the index because it has to be a cube root and not a square root. Okay, so let's try number 2. Number 2 does get a little bit harder. I gave us more variables here. We have an A, H, and K. So step 1, it still doesn't change. We're going to rewrite it with a y in place of x. Second step is we're going to switch the x and y. And I feel like all of us should be able to get here with very little understanding. But now, what goes first? How do I solve? Well, I can't do anything to the y. I can't take the cube root until it's by itself. So the first step is to add 7. It's basically like doing PEMDAS backwards. Okay, what's next? Well, next we have to get rid of the 1/3 because I can't do anything with that cubed until that 1/3 is gone. So how do I move that 1/3 to the other side? Well, I multiply both sides by 3. And the reason I multiply both sides by 3 is it's going to allow me to get rid of that 1/3. So this is me showing the work for it. Okay, so 3x plus 21 equals y plus 1 cubed. Now I can get rid of the cube. How do I get rid of a cube? I take the cubed root. So if I take the cubed root of both sides, I now have y plus 1. Okay. One more step, okay? Minus 1. Now, guys, that minus, I need to subtract 1 from both sides. I need to move this 1 over by subtracting it. I cannot put it underneath the radical. It has to go outside the radical. So my solving last step is the cube root, 3x plus 21 minus 1 equals y. Last step is to write it in function notation. The inverse function equals the cubed root of 3x plus 21. And here I have 2 more problems that are cubic. I want you to go ahead and try number 3 on your own. Pause the video. When you hit play, your answer is going to be there. Okay, hopefully this is what you got on your own. Okay, here is my final answer. Let me go ahead and explain what I did. I wrote it y. I switched them. So step 1 and step 2. Step 3 is to solve with as many steps as you need. So first I subtracted 4. Then I took the cube root. And then I subtracted 1, and it had to go on the outside of my cube root. So this is my final answer, and I wrote it as function notation. Remember for cubics that my domain is always negative infinity to infinity. Again, I want you to try number 4 on your own. Pause the video. Okay, hopefully you got this final answer. And remember that for cubics, my domain is always negative infinity to infinity for the function and for its inverse. Okay, so first I rewrote it. Second, I switched the x and y. Then I had to do PEMDAS backwards. What do I do first? I subtracted 2. Okay, next, to get rid of a cube, I have to take the cubed root. Okay, so cubed root of both sides, and I get rid of the 3. Now I added 4, but that plus 4 had to go after the radical. And there is my inverse equation. So next we're going to get into quadratics. I am going to spend a little bit more time in quadratics because, again, on video 1, when I used the task questions, a lot of students struggled with understanding what a domain restriction was. So what even is a domain restriction? What does the word even mean? Well, the domain restriction means I can't look at the whole function if I want my inverse to also be a function. Okay, so like if I look at this quadratic, the blue is a quadratic, and we learned that the inverse is a square root. But what can we, there's no restrictions here. I just graphed both of them. Is this a reflection? Is it a perfect mirror image over y equals x? Does it mirror over? The answer is no, it does not mirror over. What do you notice that about the mirroring it over? What does it have? Well, it only has half the graph, okay? So we're only going to talk about half the quadratic graph. So let's talk about the vertex of the quadratic. Where is my origin? Where is my h and k? Well, when you just have x squared, your vertex is 0, 0. And your h value is 0. So that number right here, I want us to correlate that to this part, because I only want half of my function. Now, I did make a mistake here that it should be x is greater than or equal to 0, because to be a mirror image, it should be right here, okay? So I only want this part of the graph. I don't want that other part, because if it's reflecting over in the first quadrant, it's going to stay in the first quadrant. So if I only look at when x is greater than 0 from the graph, it then is a reflection, okay? So again, I'm only going to look at when my x is greater than or equal to 0. I don't want the blue part, okay? I want what I did in black there, so that it's a mirror image of each other, okay? So my domain of my black, just the black piece I have there, my domain is going to be x is greater than or equal to 0. Now guys, don't forget, the big key here is that the domain of a function is the range of its inverse. Does that make sense? Look at that red graph. What's your range? My range starts at 0, and my range is going up, 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 and it's going to keep going up, up, up. So my range is going from 0 to infinity, or y is greater than or equal to 0. So yes, the other way is brackets 0 to infinity. Okay? Let's talk about the range of the black one. How low is the black one starting? Y is greater than or equal to 0, which means for the inverse, x is greater than or equal to 0. So you can write them like that. That is in inequality form, or you can write 0 to infinity in interval notation. Okay, so because I messed up there, I will fix that in this video here. So let's talk about this quadratic. Let's find the inverse and discuss domain and range. So finding the inverse, we're going to start with step 1, which is rewrite it with the y in place of x squared. Step 2 is switch the x and y. Step 3 is going to be solve for y. So what's the first step I'm going to do? Well, remember, I'm going to do PEMDAS backwards, so I start with adding and subtracting. So remember, we're doing this. Always start with adding and subtracting. So I'm going to subtract 4. And so I'm going to have x minus 4 equals 2y squared. Okay. Next step is divide by 2 on both sides. So x minus 4 over 2. The next step is take the square root of both sides. And when I take the square root of both sides, I then have y by itself. Now, this one's an easy one. It's a square root. Remember that you cannot leave a 2 on the bottom. So what's the first number that 2 can multiply into that you can take the square root of? Well, the answer is 4. So how does 2 turn into 4? By 2. I'm going to multiply the top and bottom by 2. So I'm going to be left with the square root of 2x minus 8 over 4 is equal to y. Now guys, that 4 on the denominator, the reason I multiplied the denominator by 2 is because I can take the square root of 1/4. So the 4 is on the bottom, so when I take the square root, it needs to stay on the bottom. So officially, this is my answer. And I'll go ahead and rewrite it in function notation down at the bottom. So the inverse function, okay, is the square root of 1/2 to 1/2 2x minus 8. Okay, now that square root, we know that square roots only look like half of a u, which is why we're going to talk about the domain restriction. So my vertex of this quadratic, my h and my k, what's inside the parentheses? Well, guys, there's no parentheses. So h and k is 0, 4. So this number right there, that number is huge. Your h value is where you're going to cut that graph in half. So my x is going to be greater than or equal to 0. Basically, it's going from 0 to infinity. My range is starting at my k value. So my range is starting at 4. Y is greater than or equal to 4. If you like interval notation, it's going up, so it's 4 to infinity. Now guys, we have already found our domain and range of our inverse. So our domain is x is greater than or equal to 4, and range is y is greater than or equal to 0. Now ready for this? Okay, I don't have the work shown for this, but remember how I told you on earlier in the video, I said you can actually leave the fraction under the radical. Your graph does graph it correctly. Look at this graph, guys. When I restricted it to x is greater than 0, I only have half of my quadratic. And when I flip it over, remember it's mirroring over y equals x. So it's folding over that line. That's a perfect reflection. Okay, so let's talk about the domain of the blue one. My domain, my lowest x value is 0. And my x value is going to go on forever. My lowest y value was 4. So this was going from 4 to infinity. And remember, they switch places. This one, the domain is going from 4 to infinity. And the range is going from 0 to infinity. Okay? So I have 3 more quadratics, and hopefully it gets easier for us. Ready? Okay. I'm going to do another one with you guys. So I'm going to do the inverse function of the quadratic. So step 1 for me was to rewrite it with a y in place of f of x. Step 2 was to switch the x and y. Okay. Step 3 is to solve it. So I'm going to add and subtract first. So what am I going to add? I'm going to add 1, because I always do the opposite of what was there. Next is to take the square root. So I'm going to take the square root of both sides. And when I take the square root of both sides, I no longer have a squared over here. Okay? If you need to see what I did this and I did this. But these basically divide to 1. They're gone. Okay? One more step is to subtract 3 on both sides. And remember that it cannot go under the radical. It has to go at the end. And step 4 is to rewrite it in function notation. So the inverse function of f of x is equal to square root of x plus 1 minus 3. If you're having to write this out, just as a heads up, you need to make sure if you can't do equation editor, I know some programs don't have equation editor, you would have to say square root of x plus 1 minus 3. You make sure you put that x plus 1 in parentheses, because that negative 3 is not underneath that square root. Okay? So let's go back to the original. That's my answer, but let's go back to the original function. What is my h and my k? H, you change the sign. So it's -3, -1. Your h is your domain. Your k is your range. So because the graph is facing up, x is greater than or equal to -3, or brackets -3 infinity. You know, I did all these with inequalities, but I prefer interval notation. My range, remember the graph is going up, so y is greater than or equal to -1, -1 to infinity. Now remember, for your inverse, they switch places. So x is greater than or equal to -1. And guys, that is your h. That's your h from your inverse. And your k from your inverse. So that's how they switch places. It's still h and k. Okay? So h and k, domain and range. H and k, domain and range. Pretty cool how that works backwards and forwards. Now here's that graph for it, just because I wanted us to see the graph. So notice that we restricted it to only half of the graph. So this is half of my quadratic. That way the inverse is also a function. Okay, so notice that these are perfect mirror image across the line y equals x. They reflect over each other. Okay, we have 2 more questions. I'm going to actually ask you to do both of these questions. So go ahead and try this question on your own. You can pause the video, and when you come back, the answer will be there. Now, guys, I got really excited working this out because in my mind, you're getting it. In my mind, it's finally clicking and making sense. So I'm hoping that it's not just in my mind. So again, look at my domain, look at my range, H and K, H and K. Look at my inverse, domain and range, H and K. That's how you're going to be able to check your work because they should be opposites of each other. Okay? So what did we do here? We rewrote it, switched x and y. We subtracted this 2, then we took the square root, and then we added the 1, and it had to go on the outside, and that was our answer. Again, if you like interval notation, 1 to infinity and 2 to infinity. Now, guys, yes, my a value was positive 1 on these. Just because I did want us to take a step back and focus on the H and K, which affect your domain and range. So let's do one more. Actually, so let's look at that graph that we just did. This graph, again, is a mirror image over y equals x. Sorry, that line's not completely straight. But that's why we had to restrict the domain, okay? That's why the domain of the quadratic was not all real numbers, because I can't reflect all real numbers and get a quadratic. It'd be a square root, and a square root function, if I do the positive and negative, that's no longer a function. And so since we're looking at functions, I only look at half of my quadratic. So I'm cutting it at the vertex. I'm cutting it at that h value, okay? So one more on your own. Go ahead and pause this video. Okay? Hopefully you got all this on your own. Okay? Again, remember, my domain is H and K. And the graph is facing up because the A value is 1. So H is a positive 2 and K is a negative 4. So my domain, because the graph is facing up, is x is greater than or equal to 2. And y is greater than or equal to negative 4. So remember, H and K. Let's look at our inverse. H and K. That's my domain and my range. Okay? So domain and range is H and K. I wrote y, switched them, added 4, took the square root, and I added 2, but it had to go after the square root. Okay, so hopefully this helped with the understanding of what a domain restriction is. Here is those graphs. This one looks a little bit different. I like this one. So remember that it's reflecting y equals x. Okay, so it's a mirror image of each other, and the blue was actually the original, and the red is the reflection. Okay, so you saw us work it out on the last page. This is what the graph looks like, and again, this is why we do that domain restrictions. So hopefully this helped clear up any of the misconceptions that we had before. If you liked this video, if it helped you at all clarify any of the domain restrictions, I'd appreciate it if you'd give me a thumbs up, maybe subscribe to this channel, leave me a comment if you want, and I hope you have a great day.